This tutorial follows on from the field data setup that we've already shown and the instrument setup for recording a set of seismic refraction data. What we're now going to show in this next tutorial is how we actually process the data that we've acquired in the field using a separate set of software. In this case we're using software called Seismic, which is supplied by Geometrics. The data set that we're going to process was acquired like this. We had 3 separate 24 channel lines, the end of which will abut onto the start of the next one. So here we have geophone locations from 1 to 24, which was acquired as one data set, 25 to 48, which was acquired as a second data set, and then 49 through to 72, which is acquired as our third data set. And when we process the data, this will appear as one continuous line, as if we'd acquired it with a 72 channel instrument. For brevity, I've shown here diagrammatically only the first 3 geophones, but of course there are 24 in each of these cases. Also, the red stars that I'm showing here, etc., are my shock points. On each of these 24 channel spreads I have 7 shock points, which I've shown diagrammatically in roughly the positions where they were in the field. So we have a shock point here and here immediately at the end of each of the spreads, an offset one in each case, one in the centre, and then one approximately at channels number 6 and number 18. Again, for simplicity, I've only shown the shock points for the first spread. Please assume that we've also got similar shock points for spread numbers 2 and 3. Processing seismic refraction data. First thing we need to do when we're processing seismic refraction data that we acquired in the field is pick our first breaks. And here we're shown how to do this using the program called PickWin, which is supplied by Geometrics. First thing we need to do is open a waveform file, and I'm going to pick the first one here, 1017, and open it. It tells us how many traces were acquired. It says 23 here because although we were using a 24 channel seismograph, one of the channels was disabled because we didn't have a geophone attached to it because of an obstruction. It also tells us what our sampling time is in seconds. So this is 0.125. It also tells us what our sampling time is in milliseconds. So in this case it's 0.125 milliseconds. And it also tells us that on each of our channels we had 4,000 data points, or 4,000 samples if you like. Now the record is brought up on the screen. It's a little small for us to work with, so we can increase its size using the blue buttons here, or similarly decrease it if we wish, and we can stretch it out in this way as well. Then also what we need to do is increase the amplitude of the channels, which we can do using the green buttons. You'll notice that we've got one dead channel here, which is why we've only got 23 channels here, and this one here is noisy because the geophone was malfunctioning or the cable was malfunctioning. But this is okay, we've still got 22 channels of data to work with. I'll just increase it a little further. The other buttons we've got up here, I can display the data in a variable area format, such as this, which enables you to see the first arrivals a little more clearly. The other thing that we can do initially is our first arrivals can be seen coming down here, and the main task that we've got is to very accurately pick the travel time, which is the time from our T0 point here across on the x-axis to this point somewhere here. Now the scale could probably be increased, so what I'm going to do is I'm going to delete this portion of the record over here, because for a refraction analysis this is irrelevant to us. So I come up here to view, number of samples shown, and at the moment it says show all samples. What I'm going to do is just display the first 1,000 samples. So the end 3/4 of the record, which was previously here, has now been chopped off. We can see all of our first arrivals, which is fine, so we're going to be able to make an accurate first break pick. And now I can expand them out a little more again, and so on. If I'm not happy with the variable area, I can take it off, I can put it back on again. The other thing I can do is I can clip the tops off the waveforms. We showed this in the field acquisition software as well, and this is quite a useful feature if some of these later arrivals start overwriting the first arrivals down here. And again, as this digital processing, we can turn this on or off depending on what our personal preference is. It should be noted that in this display our channels are horizontal, whereas on the field seismograph display the channels are vertical. There's no real relevance to this, it's personal preference, and it makes no difference in the processing of the data. Now what we can do first of all is let the computer have a first go at doing the first break picking by pressing the P button. Generally speaking, the first break picker makes a pretty good stab at it, but we're probably going to have to make one or two adjustments. So let me increase this again. And if I need to make some adjustments, for example down here, I simply place the cursor where I want the first arrival to be and click on it. Of course, it's very easy where we have a very nice sharp first arrival on the early channels, the channels which are closest to the shot point. As we go away from our shot point, the Earth tends to act as a high cut filter on the data. So as you go away from your shot point, these geophone channels down here, for example, the first arrival is a much more broad change in slope, and it is certainly more difficult to pick the first arrivals more accurately on the furthest channels. The channel that's dead here, I'm probably going to leave the first arrival point back here or somewhere like this, because when we transform the data into a time distance graph, it'll be very obvious to us that that is a bad data point, and we can edit this out at a later stage in the processing. When we're happy that we've got all of our first arrivals picked quite accurately, I've still got a bad one here, I see, I will now read in the next data file in the sequence. So I come up here to File, Open Waveform File, and I'm now going to choose 1018, Open. I select New File. Again, the little message saying I've got 23 active data channels, 0.125 millisecond sampling, and 4,000 data points. So we've now got a new record on the screen, and what is different from the previous record is we've got this green line, which is a line which is connecting up all of the first arrivals from our previous file that we've just done the first break picking. This is quite a nice feature, as it enables us to see the trend of the first arrivals on adjacent shots. And this is quite important when you're trying to pick accurate first arrivals. Again, I'll check the automatic break picker. Now our shot point was right next to geophone number 1 up here, so our arrival time is virtually instantaneous. When making first arrival picks like this, as we get further away from our shot point, you'll notice that we're picking up more and more noise. It's not that there was more noise as we went further away from our shot point, it's purely that our signal strength is much higher at the geophones nearest to the shot point. And because of spherical divergence, as we get further from the shot point, we need to increase the gain, or the trace amplitude if you like, on these signals in order to see our data. And as we're increasing the gain not only do we increase the amplitude of our signal, but we increase the amplitude of our noise, which is here. So this is why we're apparently getting noise on the dead portion of the traces before the first arrivals down here, but up here it is quite quiet. It's purely that the gain applied to these channels is greater here than it is up here. Something that I quite often do when I'm making first arrivals is, as it is noisy, it is quite often difficult to see where the first arrival truly is. But what we've also got we can look at is these secondary arrivals, and what I quite often look for is the trend from one trace to the next of these secondary arrivals. And I do this because the secondary arrivals tend to be larger in amplitude than the first arrivals. We can see, take this channel here as an example, our first arrival is a very small event, the secondary arrivals is much larger. So when I'm trying to pick the first arrival point in a noisy trace, I can look at, for example, the travel time to this peak, the travel time to this peak, and the one in the middle is pretty well in the middle of the two. So I know my first arrival is going to be somewhere about here. Now, we're not going to show picking of the first arrivals for all of the shot points. We have 21 of them. So the process that I've just shown you, you can assume that we repeat for each of the shot points, and we're now going to jump to our next processing step.